Hello, I'm Matthew, and today I'm going to walk you through how you can evaluate models using Oumi. So before I hop into things, I want to give you a little bit of groundwork about what evaluations actually look like in Oumi. And to do that, I'm going to show you an evaluation config up front. Now this config is going to be very similar to the other configs you may have seen in other videos, such as my video on training or videos on inference. So let's hop into it. So I have a config here, and let me zoom in so you can see a little bit better. But this config is going to completely describe exactly how we run evaluation in Oumi, hence it being an evaluation config. So this config will be prescriptively defining the model we're going to evaluate, as well as the tasks we're going to evaluate the model on. So the first section here should be of no surprise. This is the model we're evaluating. And for the sake of this demo, I've chosen a very small model. This is small m, 135 million parameters. And we will set the various parameters we need for it so we can evaluate this model. The second section is going to be the generation config. This is going to be exactly how the model generates results. So in this case, I'm just going to set the batch size and leave everything else as default. After that comes the pertinent part for evaluations, where the actual tasks or benchmarks we want to evaluate. Now in Oumi, we actually classify each benchmark by a backend. And a backend you can think of as just a framework for running evaluations. Right now we support 3 frameworks, and we'll go over each of them here. So the first framework is Alpaca Eval. Alpaca Eval is used for generative evaluations, and what this means is it actually needs permission to talk to another API. By default, Alpaca Eval will use the OpenAI API, so to actually run this evaluation, you need to make sure that you have your OpenAI API key environment variable set and have the appropriate key set so you can actually run against the OpenAI API. What I've done here too is I've specified the number of samples to just 3. We don't run all the samples because that's expensive to do for a demo, and we also want this to be fairly quick. We also have the evaluation keyword arguments or kwargs, and this is going to be values that we pass directly to our evaluation backend that are specific to that backend. That way we can customize and set the things that are proper for each task. Now the second task we're going to run in this case is going to be using the backend LM Harness. LM Harness is a backend that has support for many tasks. And you'll see here that we choose a very specific task to evaluate within LM Harness here, MMLU, College Computer Science. And for our kwargs, we're just going to choose, the number of num shots we're going to do, which is in this case 5, to make sure things run very quickly. Now, I mentioned LM Harness has many tasks. If you're actually curious about what the tasks are, I will give you a place where you can go and find that. So in oumi.ai/docs, let me pull that up, you'll see that we have an evaluation link on the side, and within that we have a link to the standardized benchmarks. This is a list of many LM Harness tasks that are supported within the LM Harness backend, so please take a look here if you're curious. There's also plenty more that aren't mentioned here, but we give a nice definition of these tasks, so it's a good starting point if you want to find something relevant to the work you may be doing. Now you'll notice that I did mention that there are 3 evaluation backends, and there's only 2 shown here. The last one is going to be a custom backend for running custom benchmarks. Maybe you have a new metric you want to test, or maybe you're developing a data set for a custom benchmark. We allow you in Oumi to actually implement that yourself and use it. But we'll walk through that together here in a second, where we'll make our own benchmark together. Before that though, let's go ahead and run this benchmark as is, or these benchmarks in this config, so we can see how evaluation works out of the box with predefined benchmarks. So what we need to do first, I'm just going to keep track of this evaluation config path, and let's go ahead and run evaluation. When you're going to run evaluation in Oumi, make sure you have installed the Oumi evaluation package. That's just, if I can type, it's pip install, and it's going to be Oumi evaluation. I've already installed it here, but make sure you've done that. Otherwise, you will see an error message that you don't have the appropriate packages installed. We kept them split out because unless you want to run evaluation, there's no need to add those extra dependencies to your vanilla installation. So now that I have gotten Oumi set up to go, we are good to run evaluation. And evaluation, like the other commands in Oumi, only needs a config to get going. So I'll just show this to you here. If I do Oumi evaluate --help, we can see that the only required field here is our evaluation config. So let's do it. So that's Oumi evaluate -c for our config and the path to that config, and we should be off to the races. So what this is going to do is this is going to run each of our backends serially in this case and return the results. It's going to give them to us visualized initially in the command line interface. And if we specified an output file, which I'll just quickly show you we did inside of our configuration, it's also going to, an output directory, not output file. It's going to save your results in this output directory. This is of course useful because generally you want to be able to reproduce and store your evaluation results. All right, great. So it looks like we have finished one task while I was talking, and we just have our second task, and now we are done. So let's take a look at these tasks. So after we've run evaluation, we'll output a nice table showing you the results. So we can see for our alpaca eval task, we have all the different benchmarks that come out of it, the win rate, the standard error, discrete win rate, etc., all with values that are not very good, but expected for a model of the size that we were testing. And then similarly, we have our MMLU benchmark coming out here, also again with a very low score for MMLU, but this is what we would expect for a model of this size. But now let's get into the interesting piece. Let's get into actually running a custom evaluation. So I will have a link to this code here that I'm going to show you in the Oumi repository, but this is also referenced by a nice notebook that's also currently available. What we're going to do though is we're going to create a custom evaluation that in this case is going to evaluate the model as if it was a classifier. So let's read through this and I'll show you what it does. So here we're going to give our model a prompt during our evaluation step. We're going to say that you are given a premise and a hypothesis. Determine if the hypothesis is supported or unsupported using these tokens based on the premise. So this is of course our chat template. The premise will get passed in the premise, hypothesis gets the hypothesis, and we tell the model, hey, you can think out loud, ensure that your final answer is formatted as supported or unsupported. So what we've done is we've actually found a dataset that works quite well for this. This is the Facebook ANLI dataset available via Hugging Face. If you're curious, feel free to take a look there. But what we do is we load the dataset and we format it such that we actually add labels to our dataset according to whether or not the premise is supported or unsupported by the hypothesis. So I'm not going to go through these helper methods too much. Like I said, we load the dataset, and what we do is we actually do load the Hugging Face dataset into an Oumi dataset format. This is where we format things into conversations and then make it available to use otherwise. You'll see here that I convert the labels. This dataset actually has 3 labels. It has 0, 1, and 2. So we take everything that's 0, leave it as 0, and then we clamp the top that if it's 1 or 2, it returns a value of 1. Similarly, when we're going to actually evaluate the model result, we need to record a score for the model. So we need to say that, hey, if a model returns supported or unsupported, what the actual value is. But sometimes, since this model is a generative text model, it may output both the values, unsupported or supported, or neither. So in that case, we're going to return -1, and we're going to throw out these results since they're not really useful for our benchmark. So to actually register our custom code, what we need to do is we need to interact with the Oumi registry. What we're going to do here is use this register evaluation function and register our classifier by any name we choose. In this case, we will call it classifier benchmark. You'll notice that I made this the same name as the actual function I wrote. That's not at all required. It just made sense to me to do it that way. So to make things a little bit more clear too, we'll show you exactly where we are importing this from. This register evaluation function is coming straight from the Oumi core registry. So now that I've annotated a method, we want to make sure that the annotated method always takes in the task parameters, the configuration, and the inference engine. Your custom task here, which is this function, does not have to use all of these, but it's suggested that you do because, for example, if you want to do inference on the model, we'll instantiate an inference engine already with your model loaded for you, so you don't have to do any of the work. You can just do inference straight away. So let's take a look at the logic here. This is going to be our custom evaluation function. And what we're going to do is we're going to actually grab, we'll say, a parameter called num_examples. So this will let us, maybe not run a full benchmark, but do subsets of our benchmark. And we'll load our data set using that many examples. Then, of course, we want to run inference. So given our inference engine, we'll run infer on our data set. Simple enough. And then we need to compute our evaluation metric. So for each conversation, we're going to get the last message, which is the response from the model. And then we're going to make sure that we get a prediction from it. And we're going to append the prediction and check out how things work. Now you'll notice here I'm not appropriately accounting for when the prediction is -1, but we'll use that to show how our scores can change over time and how our code can get picked up in our evaluation framework. Now, finally, given that I have my predicted and my true values, I can use sklearn and their balanced accuracy score, or BACC, to actually compute a metric that I can then return. And specifically, I'm going to return my evaluation result, and I just have it formatted here in a way that can be nicely parsable by the CLI. So let's give it a try. Now, I need to actually show you how to get this into the Oumi command line interface. And there's a great site here we have to be able to do that. So within our documentation page, again, oumi.ai/docs, let me pop it open here. We have a section on customizing Oumi. So in customizing Oumi, we explain exactly how Oumi can load custom files. Because if I use the command line interface, even though I've registered this function, there's no way for Oumi to know that I've written a random Python file somewhere. We have to tell Oumi to go look for it. So what we need to do is create a requirement.txt file and tell that to load another file. So we can do that here for ourselves. What I've done here is I have created a requirement.txt file, but it currently is empty. And let me move up so you can see that it's empty. Now, what we need to do is we need to specify the Python file this should load. So in this case, we'll give it the path to our custom evaluation. And let me just copy the absolute path. We'll just pop that in here and save for requirements. And then we are almost good to go. The next piece we need to do is actually copy our requirement.txt path. And then, according to our instructions, which we'll put back on screen for you, we need to set the environment variable, which is Oumi extra deps file. So let's try that. So we'll get rid of this. We'll say export Oumi extra deps file is equal to this file path, this requirement.txt. And then we can actually invoke our function. So the last piece we'll do then to make sure we can invoke it properly is we'll modify our config. So let's add one more extra evaluation step here at the very end. So we already have 2 tasks. Let's add a 3rd task. So we're going to create a new task. This is going to use an evaluation backend, and we're going to use the custom evaluation backend because that's what we just implemented. Now our task name is going to be the name that we just registered. So let's pop that open and make sure we know. The name that we registered here is the classifier benchmark. So we'll copy that. And let's make sure we execute that benchmark. Then we want to specify some eval quargs because we definitely don't want to load the whole data set. So let's see, we specified a quarg that was num examples. Let's go ahead and get num examples. And to be very fast, let's run maybe like 10 examples, something like that. And now we should be good to go. So if I run this benchmark again, or rather this evaluation again, it's going to run an evaluation for alpaca eval, LM harness, MMLU, as well as our custom backend for our classifier benchmark. So assuming I did everything right, fingers crossed, let's go ahead and give it a whirl. So we can just, I need to copy my location again for my config. We'll copy that path. And let's run Oumi evaluation. So Oumi evaluate -c and our config. And here we go. All right, so we're loading our configuration, and we're going to start running our evaluations sequentially. The first one being alpaca eval. Looks like that finished fairly quickly. Followed by LM harness, which is going to take just a few seconds longer. And then finally our custom benchmark. And at the end here, we should see 3 tables, which with each of the benchmarks computed as expected. Oops, I guess I got ahead of myself. That was just finishing LM harness. But here comes our custom benchmark now. We should see, I think we should end up with 3 predictions because our batch size is 4 and we asked for 10, and perfect. We're good to go. Let's take a look here at the results. So the results that we see here are as expected. We saw that our win rate and all this top 2 stayed the same. We ran the same benchmark. The bottom though, our classifier is slightly different. This is now our custom metric, which is our classifier benchmark. Great. And we see a BACC of 70. It's not quite right. That's much too high, but we only ran on 10 examples. So it's correct for what we computed, but it's not indicative of us actually being a good benchmark. Now, the last thing I'm going to show you here is exactly how easily I can change my code and update it. So in this case, our model is going to always get a 70% on this benchmark. Let's change our benchmark code slightly and let's rerun this evaluation. So say in my code, we noticed earlier that I want to actually handle the case where my prediction is invalid. That means my prediction should be a -1 as opposed to a 1 or a 0. We can see that here where I return -1 if it's returning both unsupported and supported. So let's add a case for that. What we're going to do here is we're going to say if prediction does not equal -1, then we're actually going to do this piece. Otherwise, we're just going to ignore it. Whoops, I did not mean to add that backtick. Okay, so we should be good to go. So we've made this small change. We've saved our change. Now we don't have to do anything else. This will automatically get picked up by the command line interface. For the sake of showing this to you, I'm going to make this a little bit faster by removing inside of our evaluation config the first 2 tasks, just so we can run just our custom benchmark. So let's do it. And we'll zoom back out for you. And now we're just going to run the exact same benchmark again. So Oumi evaluate, exact same file, but we removed 2 tasks and updated our 1 task. Let's go ahead and run it. And we should see a number that's probably, I'm going to guess, around 100%. We saw 70% last time, but just demonstrating how easily you can modify your code and iterate on it. All right, and indeed, we do see 100%, which is about what I expected in this case, because we threw out all the examples that conflicted that were bringing down our score from 100 to 70. So that's it for me for evaluation. To recap, Oumi has 3 different evaluation backends today that you can use. This will probably change over time, but the first is LM Harness, which you can use for our standardized benchmarks. The second is Alpaca Eval, which you can use for generative benchmarks. And the third is custom evaluations. And custom evaluations or custom benchmarks, the sky's the limit. You can do whatever you want with Oumi. They're easy to customize and they're very easy to register to use. That's it for me today, folks. And in the meantime, and until next time, happy tuning.